So today we're actually going to look at we're going to look at it's going to be more theory. It's not going to be that much of practical like the coding. I mean, a lot of coding. Today we're going to look at the literature behind data cleaning and pre-processing, and then we also look at exploratory data analysis. So with the data cleaning and pre-processing, we will clearly know the differences between data cleaning and pre-processing. We would know the similarities, some data cleaning and pre-processing techniques, and then we would also know some why are they so much important or needed in data science processes. Then we go into the second half, which is going to be the EDA, the exploratory data analysis, where we look at what exactly is exploratory data analysis, some common practices, and then we look at some types of charts, and then their pros and cons, and then what they are suitable to represent, and yeah, then we look at some code blocks of how we can actually create them in Python. Yeah, so that's what we're going to do today, basically. And it's not much. This is just 13 slides, and then the other one is, I think, 20. So we should be able to finish. And mind you, we've seen almost all of these in the programming session. So I was just trying to throw more light on it using this, what do you call it, lecture slide. And by the way, if you like my lecture slides, you know, let me know. Yeah. And if you want to know how to prepare something like this, you can DM me. I'll walk you through that. Thank you. So let's quickly go into it. Now, before we dive, deep into what we're going into data cleaning and then pre-processing, let's look at why it is so much important to clean the data and then pre-process the data. Now, this is I always like saying something very basic. Let's look at it from this angle. If you want to spark a communication with anyone, you should speak with a person in a language he or she understands. So if you want to speak with me, you should actually, spark or start a conversation in a language I actually understand. So if you come to me, you be like, hey, my name is Jonathan, and what is your name? Because I understand English, I would be able to reply. Or probably in tree, you'll be like, hey, you're saying those things. But if you come to me and you speak Spanish to me, I would just look at your face just like that. I wouldn't be able to, reply you, even if you're making sense or you're even telling me something very, very sensible, because I don't understand your language, or because the information you are laying to me is not in a format I understand or I accept. I'm not going to, agree. Same way, if you approach somebody and you don't approach the person in a decent way and you use vulgar words, the person is not going to, give in, because that is not the way the person or the format the person accepts the conversation you are trying to start with him or her, you know, um, 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 in that aspect. So a typical example is maybe you walking and you saw a very nice lady, you know, and then you be like, or maybe yeah, let's say a guy, Jonathan saw a very nice lady, be like, wow, this is the bone of my bone, probably the flesh of my flesh, right? And then you want maybe Google her number. So you go and be like, hello, if you don't speak, to in the language or maybe kind of in the way, if you don't present yourself in the way she accepts, she will just bounce you right. But if you go the way she accepts, then she would like you. Probably you get her number, you process the information, and that's the rest is actually data science and history, right? So something like that. So in the same way, now linking it back to data science, data science is the act of actually feeding computer, trying to extract information from data, and we use that. We do that using the computer. So we feed in data and we write some codes to it and other stuff. So you have to actually let the computer understand or feed information data to the computer in the format it understands. And that is what data cleaning and pre-processing actually seeks to achieve. So now data cleaning and pre-processing just transform the raw data into the format that can be analyzed by the computer. In this case, if it is machine learning you're doing, The algorithm is just a set of instructions, that runs a computer. So in the layman's this thing, or in the most basic way, let's say, the goal of data cleaning and pre-processing is actually to transform the raw data you have at hand into a format the computer can actually analyze or understand. So just like the scenario I gave earlier. Yeah. So with that being said, let's now look at data cleaning. Now, when we say data cleaning, it's just the process of identifying and correcting, errors, inconsistencies, and inaccuracies in data. So anything which is not good in the data, you're trying to identify them. That is the two technical things. The most important technical terms here are identification and then correction. So you first identify, the errors. So maybe it can be any type of error, being it errors or inconsistencies, being it inaccuracies. Maybe there is some kind of data which is not a particular input which is not in the right state or something like that. And then after identifying that, you try to correct. So you correcting it is actually, the cleaning. So you've spotted the problem and then you are correcting it now. So you are kind of cleaning. It's just like picking a very dirty something and you spot that there are dirt on maybe the particular item you're holding. So you pick a rag and you start to, clean it. And that is the data cleaning we talk of. Now, why is it so much important? Data cleaning is so much important because the quality of the data we use in machine learning or in data science modeling actually has a significant impact in the accuracy and the reliability of our sense or our findings we make. So if there is this particular and popular saying that garbage in, garbage out. So if you give in good data, you will get good results. If you give in bad data, you get bad results. So it is always key and very important for us to give in good data. We ensure that our data is actually of higher quality standards. Then we get also higher quality output that we can actually rely on with higher accuracy. Now, with that being said, let's look at some common data cleaning practices. So some of the common data cleaning practices are actually handling missing values. So in real life, you would see your data will have some kind of values missing in them, if not actually done an example or maybe a tutorial where we have the data, where we have missing data in our entries, and that is what we're actually going to do in probably our next meeting. Yeah, so we will look at data where you have some of the entries missing, some of the observations, the rows are missing. So now when you spot, how do you check for those ones, and then how do you correct them? So those things are actually you know um, that act is actually what we call handling missing values. How do we handle them? And then correcting data types. Sometimes they will not necessarily be missing data, but you will see that maybe we have ages. We all know that ages are numbers and they are integers. So we expect the data type when we do the data frame dot info, we expect the data type of that particular the age variable to be what int, but you will see it to be maybe object, or let's say a string. So although you see 18, 19, 20 there, but the 18, 19, 20 are not numbers, they are not numeric, but actually they are non-numeric, or in this case strings. So we have to correct it to the right data type, or maybe deleting unwanted data. It can be columns or rows. So you saw, I think one of this thing we dropped after splitting the date into day, month, year. We dropped the original date. So we don't want the original date variable because now we have the day, month, year. So when such a thing happens, or when we delete the unwanted part of the data, all of these, are examples of data cleaning, practices. Yeah. Now we're going to look at, take them one by one and then look more into that. So the first thing is handling missing values. Now let's look at when we have missing values in our data, how do we, actually handle them? Now this is very, 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 key. And I want you to pay much attention to it because it is something which is, something like your T in data science. Always you're going to have it, always in every data. Most of the time, your data will have missing values. How do you actually handle that in the real world? That is why I'm spending some time here. So please remove all the deaths and filth in your ears lend me your ears for these few minutes, and then make sure you take some notes and then put them in a very, the cornermost portion of your brains. So now we have two main strategies or techniques of handling missing values. And the first one is either dropping the missing values or actually imputing. The second one is imputation. Now let's pick the first one. Dropping rows, or let's say columns, either columns or rows, dropping variables with missing values, or dropping missing values. Now this approach is actually straightforward, but it can result in data loss. So the dropping rows is just like when you have rows which have missing values, just drop them, remove them from the data. So if we have, let's say, data with, let's say, 1,000 rows, and then 10 of them are having missing values, maybe the ages are missing, just drop those 10, and then now your data size is now going to be, instead of, it's now going to be 990 observations instead of the original 1,000. Now, it is very straightforward, but the whole thing is, or the disadvantage of this is that it is very simple, you just have to drop it. But the disadvantage of this is that it loses to loss of data. Now you are dropping 10, like the example I give, 10 observations of the data, just like that. That 10 rows you are actually dropping can house some kind of valuable information about the data we have. So in data science, the data is like a gold. So we don't want to drop most of the part of the gold off. You want to use all the part of the gold, just like palm tree. We want to use almost every part of it. So dropping um, the missing values in data science is not always the best practice because it leads to data loss. Now, the bigger the data, the more, the better the results. So we always want to train the model on the biggest, data we can ever find. So it's not always good you have a data and then instead of you protecting it, you're chopping some of them off. When you chop the data off, you're chopping some of the values off. So we don't encourage that. However, we do it most times. So what is the rule, or when do you drop rows? Now if you have a particular variable which has more than 50% of its values missing, you drop that variable. I repeat, if you have a column variable, I mean a column which has more than 50% of its rows missing, you just drop that variable. Why? Because when it has more than 50% of its rows missing, it has lost its value. So for example, if you have a gender column and it only has 30% of the data available, how would you know that the one missing is actually male or female, or in this case, the trans people? So it is better you drop it. But if it has more than 50%, or let's say more greater than or equal to 50% of the values there, then you don't actually drop it. So if you don't drop it, what do? You impute. So imputation, you impute the missing values. Imputation is simply means replacing or maybe filling the missing values in the data. So now when you have missing values, for example, gender, you find a way to replace the missing values. The missing values are there because of inconsistencies. It can be as a result of maybe people not filling forms very well, or maybe when you were getting the data from the source, you had some errors or something like that. They are part of us, so we always encounter them. So when you have missing values, and in this case, the missing values in that particular variable, let's say is just 5% of it, so we have 95%, then we can actually impute. So imputation is actually a technique, or data science technique for replacing or filling missing values in a data set. Now, how do we do that? This can be done using statistical methods. So we use statistical techniques to actually, find ways to, bring them back. You don't just random guess, oh, I think this gender, this guy will be a male. Then you just put male. No. What we do is we use statistical techniques. And then some of the statistical techniques are the central tendencies. I mean, the mean, median, or mode. We can also impute using machine learning algorithms, where we train machine learning algorithms to predict that particular variable, and then we replace them there. And then we have other ones using things like KNN that is k nearest neighbor, techniques and all those ones. But the most common technique used is the use of central tendencies such as mean, median, and mode. Now, when do we use mean? When do we use median? Or when do we use mode? Normally, we use mean and median for numeric, variables. That is when the variables are actually numbers. For example, age. We can find the average, the average age and then replace it with wherever we don't have the age or the age is missing. We will say that okay, if the age is missing, then we are going to find the average age in that particular variable and then represent it there. Or we can find the median and then represent it. Now, if it is non-numeric too, then we can say, for example, if it is gender, we have male, female. We cannot find a mean of male and female. So male plus female divided by 2 is actually half male, female, or half male plus female, which doesn't make sense, right? So in that way, we can say, okay, we want to use the mode, which is the or the feature that occurs most often, the most frequent observation. So if we have more females, then we can say that okay, there's a high probability this guy will be a female. So let's represent the gender by female. We can also say that okay, since most of them are females, let's represent those who do not feel as males. It may depend on the problem. Once again, when you are working on a project for somebody and you encounter this thing, report the person before, take the person's knowledge before you actually do that. So that is my advice on that. So now another thing I would say is when do we use mean, when do we use median? I've said this before and I'm repeating it. Mean, we use mean when the data is normally distributed. That is if the data is there is equal proportion across all categories. So it's like when you plot it, it's more like horizontal line. The data is equally distributed, at each point. But when the data is skewed, like majority of them are at a particular point, and then few of them are actually, in the other points. For example, maybe we can have if it is age, you can have majority about 90% of the people between the ages of say 5 and 18 and only few above 18. So when we have that, then we say that the data is skewed. When the data is skewed, it's not always good you use mean, but rather we use median. Why? Because mean is outlier sensitive. I demonstrated that with you before. So this is what I want you to take note of. This is how we can handle missing values in data sets. Now, let's look at some code snippets of some, simple error handling or sorry, missing values handling technique. Now, I'm importing pandas as PD and I'm creating a data frame, a sample data frame. Now, I say I create a dictionary with the key A and then the value being a list that is 1, 2, 3, and then none is actually representing um, a missing, means nothing, missing value in Python. So I have the fourth, value in the A is actually missing, and we have another key B, which is called B, with two missing values. The first is none, the last is none, the first is missing, the last is. So now we convert it into a data frame, saying that df is equal to pd dot data frame um, data. Now the data frame is simply something like this, rows and columns. So we're converting the dictionary, which is data, into a data frame and calling it df. You will see me using this df most of the time. Df is simply data frame, short from for data frame, and it is something I like using a lot, in most of my work. So df for data frame. Now after creating the data frame, we want to represent or we want to impute the missing values or replace the missing values in the data with the mean. So you can see that I'm saying that df is actually going to be, I'm using the fill any method. So fill any, so fill empty, fill the non values with the df dot mean. So fill the non value with the mean of that particular variable. So you can see here now we don't have any of them. Now let's look at this. So when we look at the A, we had 1, 2, 3, and then 5. So when we find the mean, it's going to be this 1 plus 2, which is 3, 3 plus 3, which is going to be 6, and then 6 plus 5, which is 11. Now, how many observations do we have? We will not count the missing value because it is missing, so we don't count it as part of the data. So we have 11, then we divide it by the number of observations. In this case, it's not going to be 4, but it's not going to be 5, but 4 because this guy here is missing. So we don't add him. So it's going to be 11 over 4, which is 2.75. And the same way, when we come here, we have only three observations available. So we add them, find the mean of those available, and then we represent it with the missing values. So we have 2 plus 3 is 5 plus 4 is 9. 9 on 3 is 3. So you can see that when we come to the B, the first was none, and now it is 3.0, it is 3, and then the last was also none, which is 3. The same way when we come here, the fourth value was none, we represent it by the mean, which is 2.75. That is how we can, this is a demo of how we can represent, we can impute with the mean. Yeah. Now let's look at how we can handle outliers. Now outliers are just extreme values that can skew the result of a machine learning model. That is the bookish way. Outliers are extreme, I like saying they are weird values in our data sets. For example, we have collection of ages of um, students in a class, and all of you, most of you, your age is will be between 18 to 25. So if we have somebody all of a sudden who is 80 years, so when you plot, you see that the 80 will be far away from you guys. All your ages will be kind of grouped together. You'll be plotted around each other, but you see this one far away. So outlier can be an extreme large value or extreme low value in the data set. So in this case, the 80 years person is actually an outlier because his age is kind of weird from it is outside the scope of the ages of our students. And then we can also have all of us, and then we see a student whose age is say 3. 3 is way lesser than what we expect in this class. So in that case, the age 3 is actually an outlier. So an outlier is simply, um, what do you call it, an extreme value in the data set, and it can be extreme lower value or extreme higher value. And when we have an outlier, it kind of skew the data. It causes the data to kind of change shape. Instead of having the normal kind of like horizontally distributed, it would be skewed either to the left or right depending on it. Now, when we have an outlier, how do we deal with it? We have two main ways of dealing with outliers or techniques. The first one is called Winsorizing technique. So Winsorizing is actually um, replacing the extreme values with the nearest non-extreme value. So that one, what we mean is, if for example, we have in this case, when we have here, let me use this data for example. Let's say the last one was 20 in the A, the 5 was 20. So 20 is out of the scope because the numbers are around 1 to 4 thereabout. So what we do is with the rasterizing technique, we just replace this, we replace the outlier here with the nearest, observation, which is going to be 2.75. So instead of 10 here, we represent it with 2.75 because that is the next to that particular, variable or that particular observation. Sorry. So that is the rasterizing, technique. Now with the another one is clipping. So the clipping technique, this involves actually capping the extreme value to a specific value. Now we can say that okay, you want to cap, kind of like cap is like capping it, chopping, giving a threshold. I want to say that okay, if you see any age which is above 30, replace it with 30 because we believe none of our students in this class is actually older than 30. So if you see 80, replace it with 30. So capping or clipping, sorry, is the technique of replacing extreme values, whether extreme low or extreme high values, with a particular number. So if it is ages, we can say that if you see any 5 years, replace it with 18. If you see any 80 years, replace it with 30. So that is clipping technique. Very, very simple. Now let's look at how we can do some kind of clipping techniques. So here we have it, we're creating another link. Please hold on with your questions. Let me finish before let me finish before you ask your questions. I beg you. So I'm actually going to. So you note your question down. If you want me to go back, I'll go back when I finish. It's just 13 slides, and we are almost there. So we actually going to be creating another data frame. So the A is actually having one, two, three. All of a sudden we have 100. 1, 2, 3, 105. You can see 100 is out of the scope of these numbers because we have 1, 2, 3, all of a sudden 100. The same way we have 2, 3, 4, 5, then 100. So now I want to say that I'm clipping in this data frame, I'm actually clipping um, the upper. So I'm saying that the highest value in this, so I'm saying that when we pick the A, the variable A in the data frame, now I want the highest value, that is the dot clip is actually to do the clipping. And I'm saying that I'm setting the upper variable upper argument to 10. So upper is like the maximum value. So I want the maximum value to be 10, and then that is the highest value in the that particular variable should be 10. And I'm doing same too for the b variable. So you can see that now when we look at the a, where we had 100, we have now 10. And in the same way in the b, where we had 10, we have, where we had 100, we have 10 now. So that is a simple clipping technique in Python, and I think it's easy. Now knowing that, let's come to data pre-processing. Now, data pre-processing is kind of different in a very technical way from data cleaning. Now, when we say data pre-processing, it involves transforming the data to make it ready for analysis, or transforming the data to make it ready for the computer to consume. Whilst data cleaning is actually the act of identifying and then correcting, errors. Data cleaning looks at identifying and correcting errors, but data pre-processing is actually transforming the data to make it ready, or to make it, to put it in a format the computer actually understands. So that is the clear distinctions between data pre-processing and data cleaning. Now when you put the two together, we have a common term called data wrangling. So we say we are wrangling the data. Wrangling the data wrangling encompasses both data cleaning and data pre-processing. So keep that one in mind. So now let's look at some common techniques, or some common, practices, common examples of data pre-processing. So we have feature scaling, we have categorical encoding, and then we have creating new features. So creating new features is actually the term we call data engineering. Data engineering is actually a data pre-processing technique. Yes, technique. So we will look more into all these examples. Now let's look at feature scaling. When we look at feature scaling, it's actually the process of scaling numerical, features to a common scale. Now we have look at a scale like we've all gone to buy meat before. We have a top pan balance at a butcher, and it has some takes a scale. So 1 to 2, 2 to 3. So it has some kind of scaling. So it is off. And the doctors too, we've seen thermometer, we have some kind of cuts, the calibrations on it, and it has a particular scale. So if it is in Kelvin, all of them are in Kelvin. If it is in degrees, all of them are in degrees Celsius. If it is in Fahrenheit, it is in Fahrenheit, right? So we don't have one value in Fahrenheit and then one value in Celsius. Comparing them wouldn't really make sense. You have to put them on the same scale, on the same unit. So that is the same thing. So scaling is simply putting the values on the same, unit. So this one wouldn't be in unit A, and the other one in unit B. That is it. Now we have two most common types of data scaling. And then the first one is min-max scaling. This involves just scaling the feature to, scaling that particular variable to only contain, for observations of that variable, to only be between 0 and 1. And we do that all to be between um, the minimum and then the maximum. So we're scaling all of them to 0 and 1. So the minimum should be 0, the maximum should be 1. So we kind of, and this is a formula. So when we pick a particular variable, which is x, when we pick a particular observation, we look at that particular variable and pick the minimum. So the x mean is the minimum, and then the x max is the maximum feature in that particular variable. So we subtract the minimum from that variable we're trying to scale, and then we divide by the maximum minus the minimum. So when let me try use this. So if we use this, let's focus on the A. The minimum observation in this A variable is 1. The maximum is 10. So if we are scaling 2, it will be 2 minus the minimum, which is 1, over the maximum minus the minimum, which is going to be 10 minus 1. So 2 minus 1 is 1 over 10 minus 1 is actually going to be 9. So 1 on 9, which is going to be a point something something. So, scaling will actually convert all the values to, a scale, a particular scale, which is between 0 and 1, using the minimum. So when we use the min max, we use the minimum and then the maximum, values for scaling. Now we also have another one called standardization. Those who are so much into maths, you know the z value, the t table, and then sorry, the z table rather. So, you standardize the data, and that involves instead of using the minimum and maximum, you find so the mu here, mu for your information, you've not seen this before. It's a Greek letter called mu, which is actually used to represent mean, and then the down here is called sigma. Sigma is always used to represent standard deviation. So to standardize a particular variable, just as we saw up there, we pick that particular variable, subtract the mean, sorry, we pick that particular feature, subtract the mean of that variable divided by the standard deviation. So if I come here, let's pick the A again. Now let's say the mean is say 5. When we calculate, so 1 plus 2, which is 3 plus 3, 6, 6 plus 10, 16, 16 plus 5 is 21. Yeah, 21. 21 divided by 5, I don't know, you can do the calculations. So you have the value and then you subtract. So when you want to scale standardize 2, it's going to be 2 minus the mean we had over the standard deviation, and then it's going to give us a value which is going to be a decimal. So when we actually transform all of them or pre-process all of these, they would be on a common scale between 0 and 1, and then it helps the machine learning algorithm to really understand it better than the old ways we do. So that is your information, and for your information, we will look more into this later, in the future. In the future, this thing when we go into the programming. Yeah. And now we can even see some um, programming, here. So we are importing pandas and from the scikit-learn, that is sklearn plus preprocessing. We are importing min max scaler, that is for min max scaling, and then we create the data frame here. Now we are actually instantiating the scalar to be, so scalar is equal to min max scalar, and then we actually scaling the A and B. So when we pick this, you can see that, let's try. You can see that the first one of A is 0. So how did we do that? So it is x minus x mean over x max minus x mean. So when we pick 1, 1 minus the minimum value in this is 1. So 1 minus 1 is 0. So obviously everything will go to 0. So when we pick 2, it's going to be 2 minus 1, which is 1, over the maximum, which is 5, minus 1, which is 4. So 1 on 4 is actually 0.25. When we pick this, it's going to be 0.5, 0.75, and then 5 minus, um, so 5 minus 1 is 4 over 4, which is going to be 1. That's why we get this here. So we will look more into this when we do the programming more. And I'm also going to share the slides with you so that you can reference them anytime. Now let's look at encoding categorical variables. Now, computers only understand numbers. So anything you give to the computer, being it a picture, a video, a text, a word, it breaks it down or it converts it into numbers so that it can understand. So the act of converting anything you give to the computer into numbers is what we call encoding. So we say we are encoding. We are encoding, meaning we are transforming the text or whatever, the video, the picture you are giving to the computer to digest into you know um, into numbers. So when we go further, or when you go further in data science AI, you would see that even pictures, the picture you see, like the picture of this slide, is full of numbers, some small dots, and it full of like billions of dots put together will form the image. And each dot has a number. And so this picture here is full of numbers. So a lot of numbers put together form this picture. So that is it. So the act of actually converting numbers, converting whatever we give to the computer to numbers so that you can understand is actually called encoding. It is very you know, important because sometimes the data we supply to the computer isn't in, you know, numbers. For example, gender, we have male, female. So we can actually encode the gender and then we we help. So with the encoding, we can tell um, the computer or Python that 0 means male, 1 means female, and then it will just understand. That way, it will understand that you say male, female. It doesn't know male, female. Yeah. So there are some few examples of, there are a lot of millions of examples of encoding techniques. I'm just going to speak about these two. When we go into the programming or with time, we would employ them a lot. So we have one hot encoding, and this involves just creating a new binary. So when we have one hot encoding is actually a technique where we just create new variables and say if it is male. So if 0 is for male, wherever we create a variable called 0, and then if or we create the male variable. So if that particular gender is male, we represent it with 1. If it is not male, we represent it with 0, something like that. And labeling and coding, actually we it involves, or we use labeling and coding when we have categories. For example, um, we have, let's say, education. We have primary education and basic education. We have junior high education, or they are all basic education, right? Yeah, basic education, secondary education, bachelor's degree, um, master's degree, PhD. So these are categories. One category is actually different from the other. So when you want to encode, you can say that okay, one should represent basic education, two should represent high school education, bachelor's is three, four is masters, and five is um, what do you call it? PhD. So wherever you see five, you know that it's PhD, something like that. That is labeling and coding. We have other ones like ordinal encoding and a whole lot of them. We will look more into them. But now I want you to know, I want to enlighten you so that you know that there is something like this. So when we go into the programming, you won't suffer. Now, here is an example of a code showing one hot encoding. So one we can see we are importing the one hot encoding from the scikit-learn.preprocessing um, module, and then we imported one hot encoding. Now we've created a data set which has gender, and then we're saying that the gender, sorry, gender is actually male, female, male, female, male, female, male, male, female. So now we're saying that we want to instantiate the encoder, and then we kind of transfit the encoder into the data frame, and this is what we have here. So it's actually, if you look at here, it has created two different columns. The first one is 0, second one is 1. Now it is assigned 0 to, you can see that it's assigning 0 to female and then 1 to male. So if you pick the 0, we now come to the features in there. So the first one was actually male. So since 0 stands for female, when we come to the, this is actually female, this is for female, this is for male. Now when we come here, ask was the first observation male or female? You can see that it is male. So it will come to, since it is not female, it will put 0 here in the female column, come and put 1 in the male column. And then when we come to the next observation, it is female. So you can see it puts 1 here. The second observation is actually female, so it puts 1 under the female, which is 0, and then put 0 under the male. The same way, the second one, second and the third and fourth are males, so you can see 1 1 under the male and then 0 0 under the female. And then female is the last, which has 1 here and 0 there. So that's how it does the one hot encoding. Yeah. Now it is, we will look more into that, don't worry. But I just want you to have a few, a taste of that. Now let's come to creating new features. Now this is very common. So sometimes we can create new features out of data by combining existing features, either two or more of them, and then it helps us to create more data, and then the variable, or maybe or let's say we will have more information added to our data set. So we have this data frame, which is actually height, just height, and then weight. So we have the height and weight. Now we are actually creating BMI, body mass index, out of the height and then the weight. So BMI is actually, the formula is weight over, I don't know, is it weight over um, height over 100 times, 100 squared, something like that. Zainab will know more. Zainab will tell us more. That is a formula. I don't know much about that. I think I just created the formula. So this is the formula. So it's actually like this. So this is how we calculate. I was just kidding. Let me explain the BMI. If I get this wrong, Zainab, you explain it better to us. So the BMI is calculated by, we first divide height by 100 and square it. Now, after having that height divided by 100 squared, now we divide this calculation here by the weight, then we get BMI. So you can see that this guy has a height of 170, weight of 65, and his BMI is 22.49, and same for others. So we didn't originally had BMI index or BMI variable in our data set, but we've created BMI out of height and weight. For example, yesterday or on Sunday, we actually created day, month, and year variables out of the date variable. So that is a clear example. So that is how we can actually combine two or more, or just one variable and create another variables from that particular variable. So this is what I wanted you to know in the first part of the lessons. I would like to take your questions. That is all I have ended. So I would like to take your questions and then begin the second one, and we're good to go. So if you have any question, just raise your hand and then let's go. Any question or we are cool? Are you cool? Okay, Abubakar. Abubakar, just raise your hand. I call you then for so that we don't. But you can unmute yourself if you have a question. Unmute yourself and speak.
I just wanted to say maybe we'll go over it and then maybe if you have questions will come.
I should.
No, I mean I'll go over it or let me speak for
Oh,
myself.
okay.
I'll go over
Oh,
it and
okay.
then if you have questions.
Okay, that's fine. Jonathan, Anamwa, Bryce, Anakufi, Aduse, Zainab, any questions?
Okay, let me.
Okay, Jonathan, go ahead. You can go ahead.
Okay, so I wanted to ask, um, looking at the 0 and 1, the way it's outputted it, could there be a way where it's outputted it like more or less like the initial how we wrote it initially, but just that like in the form of a dictionary, but it's not more or less like coordinate, but it's just the male becomes 0 and the female becomes 1.
I don't get you. Try come again. Mind you, it's
So
not a
yes.
dictionary, it's a data frame.
Oh, okay.
Yeah,
I
so we
see.
created a dictionary, and then we are, we can see data is equal to the dictionary here, and then we are actually converting the dictionary into a data frame using the PD of data frame and storing it in a variable called df. So it's now a data frame, and a data frame is what we actually, fitting things on, not the dictionary you see here. So maybe you can come up with your question now. Maybe I understand.
I get why it's outputted like this.
Okay, you thought it was a dictionary.
No, I was thinking maybe it can like output it as a dictionary.
Well, that is if you format it that way, it will be fine. But I don't think because I am actually there. I'm saying that df encoded is actually should be a data frame. You can see it here. So that is
Yes.
why it's in that form. So you can do that. If I format it as a dictionary, it will do that. But it wouldn't make any sense. This is always the best way to, you know, represent it. Okay. Nanamwa, go ahead.
Please, I would like to ask that the 0010 are they representation of male, female, male, male, female, or I don't understand.
Which 0010, please?
The output, you see,
Okay. So
the 00,
is it the ones in the columns or the ones in the rows?
okay, the ones in the row, column, sorry.
So the first column is zero. The first column title is zero. That is for females, right? For female, one is for male. That is how it's actually encoded it in there. That is how it is going to take it. Now, so see the zero as the top one here. Let me go there. This guy as female, zero as female here as the header, and then the one as
Okay,
male. So now we ask ourselves in the first observation, was the gender male or female? The gender was male.
male.
If it is male, go and put one under the male and put zero under the female.
Oh,
The second person
okay,
was a female. Now we put one at female and zero at the male in that order.
okay, okay,
Yeah.
okay,
So that's why we call it one hot encoding. So it's more like we're looking at one side. You get it? It's like a switch on and off.
okay,
If it is not on, it is off. So we're
okay,
operating between zeros and one. Yeah.
okay. Thank you very much.
You're welcome. Okay, Bright, go ahead.
Okay, so I wanted to clarify something on filling in the missing value with the mean and also the clipping method for handling missing value. Per your explanation, you're more like you're going to set a certain value for the missing values. For the clipping, it's like maybe you can choose that um, the highest value is supposed to be 20. So any other value that's above 20 will be reduced or will be clipped to 20. And filling in the missing values to with the mean. Let's say the value that you've chosen to replace all missing value is the mean. So is there any relation or they are kind of the same by different principles?
So let's take it like this. You know, if you're working on anything, you would that's why I always say the first thing is to understand your data, right? So you know your data and you know the one you're working for. So if, for example, I'm working on something for this class, I can maybe ask, I can come and ask and know that, or I know my students, I know that none of you would be 80 years. So if I have so the clipping, or even before that, um, the failing with the mean is actually mean the mode is how we handle missing values. And then the clipping is how we handle outliers. Outliers are extreme values. They are there, but they are extreme, way bigger or way smaller. The missing values are not there. So we can impute. So we impute missing values and then we can clip or visualize um, an outline. I don't know whether you get to me.
Yeah, thank you very much.
You're welcome. Any other question? Zainab, are you cool?
Yes, I am.
Okay, that's nice. I hope I got the BMI right.
Right. The BMI.
Yeah,
You were saying something divided by 100, or wasn't that one?
yeah.
It's actually the weight over the height squared.
Any Charlie,
So the
Mukwa no
weight in
Makwako,
kilogram,
boy.
height in meters. So, right.
That's fine. So when you go, you do your own. You look at the formula and then you write it, and then it's just a demonstration of how you know we can create something, a new feature out of the system. And thank you very much, Zainab, for
You're welcome.
correcting us. So guys, if you don't have any other question, should I share the next slide? We move on.
Yes, please.
Yes.
Okay, that's fine. So all of you still, you will not share your screen. You will not share your this thing. I mean, your faces. You want me to call you Cobra? I see. And put it in presentation mode. Now this one we are not going to do it more like the data cleaning. We've done this over and over and over again. So I'm just going to explain, kind of brush through, and then you go over. I think it's self-explanatory. We've done. So we're going to look at. Before, let me take my water. Before my throat is dry. Sorry. So we're going to look at exploratory data analysis. What is data? Exploratory EDA. I'll be using EDA. I don't want to slip off and you laugh at me. So EDA is the term or the short form of exploratory data analysis. And we're going to look at what is it, why is it so much important, how do we do it. So now, this slide is kind of populated because I wanted to put in much text so that when I send to you, you can use it as a reference system. Normally, I don't do my slides like this. I do very, very few things and then I go my way. So exploratory data analysis is just the process of analyzing and visualizing data to extract insights, and identify patterns. So this is the bookish. In my own ways, I would say, when we say you are analyzing something. The guys, for example, you say, Charlie, after football, you say, you sit and do some analysis yourself. You see, Kante didn't play the ball. He should have played it to this angle. If he had given the ball to this guy would have, chipped the ball in. He shouldn't have even played it, on top of the keeper. He should have passed all those things. So you are actually, now reflecting, looking at the scenes and then making some meanings out of it, right? So that is the same way coaches do. After matches, they go and sit down and then watch the match errors and everything, and then get some meaning out of it. That is analysis. So in data science, we deal with data. Before you can solve a problem, we're trying to solve problems with data. Before you can solve a problem, I think you should know the problem well before you can solve it, right? So if you want to solve teenage pregnancy, you should understand or know the main causes, the root cause of teenage pregnancy, and all those things. So that is what I think, yes, and that is what is actually it. So you know the root cause. That is what exploratory data analysis seeks to achieve in data science. So exploratory data analysis is actually the process of scrutinizing, kind of diving deep into your data to explore, the hidden secrets to know that, okay, this thing is this thing is that, and then it will help you to, make better, you know, to help solve the problem in the best way. That is it. So there are several, steps in involved in EDA, and I'll take them, one after the other. So the first thing is data cleaning, and then from after cleaning your data, because you cannot do analysis if your data is not cleaned, because first you have to make the data, put it in a way the computer can understand. So the first step is data cleaning and pre-processing. So we clean our data and pre-process everything, and then the first step after cleaning, then we come to univariate analysis. That is analyzing, we pick the single variables. So when we pick a variable, we try to analyze it solely, and then the individual, we analyze the individual, variables. That is the univariate analysis. Then when we finish, we can look at bivariate. So bi means two, how this variable actually, relates with the other one. So we pick two things and we look at how they relate, and then we extend it from one to two to, more than two. That is multivariate analysis. So after knowing that, then you know we visualize our findings so that we kind of create visuals, kind of like um, charts, like bar charts and all those ones there, to show that, okay, this is that, this is that. So that is actually what, the EDA, process. Yeah. So now let's look at data cleaning. I'm not going to talk much about data cleaning because we looked at that before. That's a way of, cleaning your data, and then it is important because you have to clean your data, put it and pre-process it and put it in a format the computer understands. Now let's look at univariate analysis. Like I said before, it is actually the way of analyzing the single, or individual variables to understand their distributions and summary statistics, or to understand them. So some of the techniques or some of the ways we can do is actually plot something like histogram. When you plot a histogram, that is one of the most common things we actually do. So we plot histograms to on the individual, variables in the data sets to know that, okay, this is how this data is actually distributed, this is how this data is distributed, and then we can do the df dot describe to, describe that particular, variable, and then we go. So this is like a summary code of, you can see here, down here we have to describe. So we can pick a particular, column and then describe it. And then we can also plot a histogram. Now when I send it, you can look more into the codes and then maybe try to implement them to see whether they work. Now let's look at bivariate, analysis. So with bivariate analysis, we're looking at the relationship between two, you know, pair of variables. So we're looking at how this affects the other. So not just the variable itself. So we can actually we can actually perform things like um, correlation. Correlation is a very common thing. How does it correlate with how does this column A correlate with how does age correlate with height? Maybe the more you grow, the you know the more your height increases. How does, or maybe the otherwise, or how does age, relate with um, mental toughness and all those ones based on your data. So you're looking at how does this particular variable relates with the other, and we can do those analysis using things charts like, or we can even do correlation, and we can use heat maps, we can use scatter plots, to represent that. So you can see how we do correlation in Python, and then we will look more into that, later. That is the next meeting we meet, and we can also plot a scatter plot. To, scatter plot is the dot 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 ones. We will see that later in these slides. So I'm just trying to establish to you what we mean by bivariate analysis. And then multivariate is simply, more than two, variables. Analyzing how more than two, let's say three, four, five variables, talk to each other, how they relate. And the most common, way to do that is actually use the what we call correlation again. So correlation both is used for both bivariate and then multivariate, analysis. So my TA is here, finally here. I'm happy. TA, welcome. How are you? So we we
I'm doing well.
oh, that's fine. I'm glad. So we're looking at, I was talking of multivariate analysis. So correlation is used for both bivariate and then multivariate analysis. So we can do the correlation of all the numeric variables in, you know um, the data set. So if you don't know correlation, correlation is a statistical technique or a statistical technique for looking at the relationship, between variables. So how, if this is going up, what affects to, or what is the effect on this particular variable on the other. Yeah, so that is correlation. And then we can actually represent correlations with heat map. Heat map, we will see how to do that. And you can see how I've imported here. I'm importing a new data visualization um, library called Seaborn, and I'm importing it as SNS. Now in Seaborn, I'm actually plotting heat map. You not see it here, but you see it later. You can also do the pair plots to do all those ones. But for now, put it in mind, multivariate analysis is actually you know um, looking at doing analysis on more than two variables. Now let's look at the visualizations. Visualizations are a very important part of EDA because it allows us to see the patterns, in relationships in the data. The rest you can read. You know, there is this say in data science that pictures tell more, compelling stories than, numbers. So if I show you a picture, you can easily see that, oh, this is that, something like that, and to show you tables with numbers and all those stuff. So we always try to visualize our outputs to make it very easy. And in Python, we have visualization libraries like Matplotlib, Seaborn, Plotly, and then we have even ggplots and all those ones. We will look more into that, but the most common ones are Matplotlib and Seaborn, and we will look at almost all of them. Don't worry. So now let's look at some of the um, charts. I mean, yeah, the charts and what they are used for. So the first thing is histogram, and a histogram is actually a graphical representation of a distribution of a data set. So histogram is normally used to look at the distribution of a data set. Histogram is always used for univariate, data analysis. So when you want to do analysis on a single, variable, you want to see how it is distributed, how age is distributed across the class, then you use histogram. So it is used to show the underlying frequency distribution. That is how the data is distributed, of a set of continuous or discrete data. So we can have continuous or discrete data. Continuous data means that there is no gaps. So it's like kind of like continuous. And then when we say discrete, it's like you can count them. So one, two, three. Yeah. So that is what you should know. So, and we can create histograms using all the data visualization techniques or libraries, sorry, in Python. So this is some kind of pros and cons of histogram. So the pros are the positives. So histogram is always easy to interpret. It can help you to know the distribution, whether it is normally distributed or or it is whether it is normally distributed, uniformly distributed, or it is skewed. And if it is skewed, is it rightly skewed, or positively skewed? Is it negatively skewed or left skewed? So that it is very easy to interpret and very easy to create to, and can handle large data sets. So when we have even millions of data sets, you can just do um, histogram on it, and then we can easily do that. And then it shows the shape of the distribution. Like I said before, tells you how the thing is distributed. Now the negative side or the cons is that the bin size can impact the interpretation. Now, the bins are actually the number of the blocks you have in it. If you're not technical, maybe if you expand, increase the bins, you will see clearly how the data is distributed. So sometimes if you use 5 bins, you will not see clearly the distribution of the data as compared to using 15 bins or maybe 10 bins. So The beans can actually be misleading. And then it can also be misleading if not presented properly. That is it. Every chart, if you don't present it properly, it can mislead you. You can interpret it wrongly. That is the only cons of um, histogram. And this is a code snippet of how we actually create histogram in Python. And with 20 pins, this is an example of histogram. Very nice. And this we can see that this is actually normally skewed. Most of the data is actually between -1 and 1, and it is like kind of chunk. It is bell shaped, kind of like the shape of a bell. So it is when we have a data like this, we say it is normally distributed. It follows a normal distribution, and the mean is actually around 0, the standard deviation of sigma, right? So this is an example of histogram. If you don't know that, yeah. Now let's look at scatter plot. Scatter plot, for your information, is actually a bivariate, data analysis tool because it helps you to plot two things, one on the x-axis, one on the y-axis. Yeah. Please hold on. Let me attend to something. So guys, sorry about that. I had someone seriously knocking on my door as if she wanted to break the door. So I had to. Sorry, my bad. Um, so I was saying that scatter plot is actually a bivariate, data analysis tool or visualization tool because it plots one thing, one variable on the x-axis and the other one on the y-axis, and then it represents the relationship between two continuous variables. We have two variables. We're looking at the relationship between them. So are they actually? So it's more like it tells the correlation. So if they are actually in the form of a line, you can say that okay, this one is actually it is having a strong or weak correlation, and is the correlation negative or positive, something like that. So it is also used to identify patterns and relationships, like just as I said. You want to know how this one relates to the other, how X relates to Y or something like that. So scatter plots are useful for identifying outliers, correlation, and classes in data. So like I said, if you plot and you see if there is an outlier, you see that it has kind of isolated itself. So you can see that okay. And sometimes when you plot, you can see that there are some subgroups in the data. You can see that subgroups, the groups are what we call clusters. And we will look at clusterization in machine learning, that is unsupervised learning, which is going to be very, very interesting. But for now, no scatter plots. And then the pros and cons of it. The pros are that it is easy to interpret, it shows the relationship between two variables, and can handle large data sets. The only con is that it can be misleading if not presented properly. And this cuts across. If you don't present the meanings very well, you can mislead yourself. Yeah. Now this is how a code snippet of how we can present, how we can plot a scatter plot using matplotlib in Python. Now this is an example. So we have X and Y. You can see this, they are kind of like forming a line. You can see that they are kind of moving some this way. So this is actually, we can see that since they are kind of close, the dots are kind of close to each other, we can see that it has strong correlation, and in that it is positive because it is moving this way. We will know more about correlation. Don't worry, but this is an example of scatter plot, and it is used for bivariate analysis because we have one variable here then another variable on the y-axis. Yeah. Now let's look at bar chart. So a bar chart, the first thing I would say is it is a multivariate, and data analysis, chart. It can be bivariate or multivariate. When we plot bar chart of two things, you know, maybe gender, male and female, it becomes bivariate. But when you have more than two, maybe in the case of university, categories, or let's say um, educational categories, junior high or basic education, second cycle education, bachelor's, all those things. When you have more than two representations, we have what do you call it? Multivariate. Now, bar chart is a graphical representation of the frequency distribution of, so it shows how much frequencies are in each category. So we have male and female. How many people are male and how many people were female? Something like that. How many people have BEC certificates? How many people have overseas bachelor's, master's, and something like that? And it can be created using all the data visualization libraries in Python. And the pros is it cuts across all of them. So um, pros is that it's easy to interpret. It shows the relationship between a categorical variable and a continuous variable. So it can be used on categorical variable and then um, um, continuous variable. And we will know more about categorical and continuous whilst we go to the programming session. Now the cons is that same way it can be misleading if you don't interpret it well. Now this is how a simple code to show how we can create um, a bar chart, and this is an example. So you can see a very nice bar chart. So normally it shows the relationship between variables. So we can see that okay, a lot of people. So the highest category here is E, followed by B, followed by C, D, and then A is last, something like that. So it shows the relationship between variables. Yeah, and it is used for either bivariate or um, multivariate analysis. So I don't want to see you using it for univariate analysis. Now let's look at box plot. Box plot is actually a univariate, you know, um, a univariate data analysis chart. So it tells you just like histogram, it tells you the distribution of a data set or a variable. So it's also used for detecting outliers and all those stuff. And then it is used to show the mean because it shows the median, the quartiles, and outliers of a continuous variable. Box plots and histogram are very useful for detecting outliers, and they are also for univariate analysis. Now, box plots are useful for identifying outliers and comparing distributions between, so we can also use for comparing distributions, and then it can be created using all the using matplotlib and all the other listing. And then the pros is that it shows the mean. It can actually, the summary of the pros is that it can, help us to detect outliers and it can compare distributions. Now, the cons is that it's not useful for showing the exact distribution, but it is useful for showing outliers. And then it can also be misleading if you don't interpret it well or present it well. There is a code for showing a box plot for a box plot for creating a box plot using um, matplotlib. We can use Seaborn, we can use plotlib, we can use all of them. Now, um, so this is a box plot. Now, some people call it box and whiskers or whisker plot. Now, the box is this part, and the whisker is the out those bars outside. Now, the center here, this line here is the median. So if you have a box plot which has the center, the median right in the center like this, then we can say that it is kind of uniformly distributed. And if there is an outlier, you will see the outlier outside the whiskers. You see some zeros here telling us that they are outliers. And then the lines or the length of the whiskers, these lines wouldn't be uniform like this. One will be longer, one will be shorter. So it tells us and then we will know more about that. But now I want you to know, how. So box plot is used for univariate analysis, and it's always used for detecting outliers. Now that is the conclusion. So visualizations we've seen that are powerful to remediate and allow us to quickly identify patterns and relationships in data. The choice of visualization again depends on the type of data and the research question or the problem at hand. So we can have univariate, bivariate, or multivariate analysis. We don't interchange them. Yeah. So I'll share this thing with you. But now let me take your second round of questions before I share that with you. Yeah. I hope I didn't run too fast. Let me know your questions, please. Oh, you know mine. Zainab, do you have a question? Um, Nanamwa, do you have a question?
No, please.
Okay, Bright, any question?
No, I don't have any question.
Oh, I'm good. Jonathan, any question?
No, please.
Nana Kofiadi says he doesn't have a question. Mighty, do you have a question?
For what I think, is I don't have a question, but I might have questions in the previous one we did that I wasn't part of finishing. Maybe I'll let you know.
Okay, so when you watch the video and you have any questions, you can always forward them to me. So, guys, I think we've done a lot today. Um, I want to, I want us to rest here, but before, let me even. So that's all for today. Let me stop the recording. Then I talk to you about